Hello everyone, this is Miss Cromwell with this week's math homework. And this week's math homework is our quarter one CSA. It is our study guide that we will be going over later in the week. If we don't do it on Thursday, then definitely on Monday, the following Monday. So I'm going to go over these. Hopefully I don't take all of y'all's time, but also trying to stay thorough. All right, so number one says, how is 530,600 written in standard form? So students have been told to box it in. So the first part, box in until you see the comma, which would be this part. After we've got it boxed, now we want to look at it. It says 530, all right? So we can either ask the student, how do we write 530? So we could do it this way, 530. Or some students have a hard time with that. And then, they'll see 500. So let me cover that up. They could say 500. And then 30, you could add 30. And then again, if you add, your ones place, your tens place, your hundreds place, you have 530. Okay, so that's how we get 530. When you see the word thousand, that's when you're going to know to put your comma. And then the next part says 600. Well, how would you write 600? It is like that. So that is how you would write that one. So B would be your answer. All right, the second one says to write the answers on the correct line. It says label the place value position for the digits 5 and 2 in that number. So what I would strongly suggest and what students should be required to do is on top of this number, either on their paper to write it on top, but as far as show work during a test, they would need to do their place value chart, which would be one tiny hippo thinking 10,000 happy thoughts. Okay, it's a little hard to see. If they need to write it on the side, that's perfect. One tiny hippo thinking 10,000 happy thoughts. Do your lines. And then your numbers. 829, 829, 537, 537, and oops, I made an extra line because I was trying to go fast. Sorry about that. There we go. Either one works. And so then it says for the digits 5 and the digit 2. So what is the place value for the digit 5? If I look over at the 5, again, whether I wrote it directly on top or if I did my own place value, it's in the same spot, you'll see it's TH, and TH means thousands. So they need to write thousands. And then what's the place value for the digit 2? Find your 2. It's just a T, and T stands for tens. All right, number 3, it says, which shows the expanded form for the number 605,034. Students were taught when we did this to start with the largest, or the digit in the largest place value spot. So in this case, it is a 6. You write the 6 directly underneath, and then every other place that came after would be a 0. So 0 is in that one, that one, that one, that one, that one. All right? And this is to help students realize that, yes, it's 600,000, but how many zeros do we have? It's 1, 2, 3, 4, 5. So then we're going to look through here for a 6 and 5 zeros. 1, 2, 3, 4, 5. So just knowing that one right there, we're already taking 2 out because there's only 2 that have 600,000, which is a 6 with 5 zeros. A lot of students are like, oh, I can do this in my head, and I love that. However, many students are getting very confused with how many zeros. So please, please, please have your students make sure they're writing the digits directly underneath the number. There's a 0 in the 10,000, so we don't have to do anything. In the thousands, you have a 5, so we're going to write a 5. And then again, everything that came after has a 0. So now I see I have a 5 and 1, 2, 3 zeros. And so if you're doing it correctly, you could already see that D is going to be your answer because this one has 4 zeros. Okay. But to continue on, there is nothing in the hundreds. There's a 3 in the tens, so I'll put a 3 under the tens. Everything after is 0, which is 30, which is also right here. Lastly, there's a 4 in the ones, so you would just write the 4. And then if you add them all up, because that's expanded, you'll have 600,000 plus 5,000 plus 30 plus 4, which is answer D. Please remind your students we do have to have show work. It's not optional, even on your CSA. So please make sure your students understand that. All right, number 5. Oh, hold on. Missed number 4. Let me pull it down. All right, number 4. It says shade each box you want to select. You must shade all the responses. Which model shows a way to represent the number 238? For this specific one, on a computer, they're going to have to click them. All of these will be clickable, and students are going to have to count every single one to determine how much it is. Sometimes it might just be 1. Sometimes it could be 2. Sometimes it is 3. So there's really no easy way of knowing if it tells you to select all of the correct responses. Okay, so if we're looking at here, we see that these are flats. That's 100 and 100. So I'm looking how many flats do I have. I could do this many ways. I could, 100 plus 100. But I see I have 2, so I'm just going to put 200 here. These are rods, and those are sets of 10. There's 1 rod, 2 rod, 3 rod, or 10, 20, 30. And then now we count up our ones, or our units. 1, 2, 3, 4, 5, 6, 7, 8. And if I added those together, so 200 plus 30 plus 8, in my ones I have 0, 0, and 8, so that's 8. My tens I have 0 and 3, which is 3, and then 2 I have nothing to add, so 238. So does this one equal or represent 238? Yes. So students can either choose, they want to do a check, that's fine, or if they want to lightly shade, that's fine, whichever. But we do want to see that they did, in fact, count them and add them up. We've tried teaching students to make sure they are crossing off their models as they're counting, just to help them have a less chance of making errors or, forgetting to count something or counting something twice. Okay, so over here, again, I have 100 plus another 100. So 100 and 100 is 200. So I'll put 200. I have 1 rod, which is 10. And then here's where it gets a little trickier, because we are going to add all these units, all these ones. However, some students like to group these up. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they like to circle those. That is an option. Some students like to just add all of them and then write that number on the side. Either works as long as we can tell that your student, in fact, did count them. Okay. I'm going to do the circling method because I personally feel that it's easier to count by tens and then less likely for mistakes, because I've realized that several students, when they are counting, some students are having a hard time reciting, like just counting to 100, and that we're missing numbers, or they'll skip around a little bit. So here we go. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, we had already put a 10 up here for the rod, so it's up to your student. Most students looked at this and like, oh, I can see that there's going to be more than 10. So before they write it, many students will want to group that, which is fine. And then students could say, okay, 1 rod is 10, that's 20, that's 30. It would work. Some students want to say, all right, that's 10, but then we have 10, 20 here. And then adding these, 1, 2, 3, 4, 5, 6, 7, 8. And then again, if we add them all together, 200 plus 10 plus 20 plus 8. Make sure that your student is keeping their stuff neatly lined up so that way they are adding correctly. So 0, 0, 0, and 8, still 8. 0, 1, and 2 would be 3. And then 2 and nothings is 2. So we see that this one is also 238. So you would either put a check mark or, gently shade, whatever your child prefers. Okay, so this one, again, we have 100 and 100. So 100 and 100 is 200. I see that I have one group of 10. I have one group of 10. I see I have a whole bunch over here. I bet you there's more than 10 over here. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to circle the ones I just counted. And then some students are able to visually see that it's not full right here. So it's not 10. Other students are going to want to count. Either is fine. So we have 200 and then 10, 20, 30. And then how many units? 1, 2, 3, 4, 5, 6, 7, 8. So 238. It's also being represented. So again, this one is also a check mark or, whatnot. Over here, we have 100. And then we're counting by tens because these are our rods. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So some students like to group those because that's 100 and 100 is 200. So I'm going to go ahead and write that. 100, 100, and then 1, 2, 3, 4, 5, 6, 7, 8. So if I had to do those separately, it would look like that. So in my ones, I have 0, 0, and 8. My tens spot, I have 0 and 0. And then my hundreds, I have 1 and 1, which is 2. This one represents 208. Is that the same as 238? And the answer is no. So this one is a no. So it would be an unshaded or, a large X. That one does not work. Last time we sent home a study guide, students were just memorizing the answers, which is not helpful because the study guide is not the same as the CSA. There's many similarities, yes. Many of the wordings the same. However, it will never, ever, ever be the exact same questions with the exact same numbers ever. And same thing with like the responses. Like just because it's these 3 does not mean it's going to be those 3 on your test. So please, if you know your student just likes to memorize answers, please remind them that it is not going to be helpful. They will get more wrong if that's the case. All right, so number 5 says, which statement is true? And students for each of these will just have to work them out. We learned in class to stack. There's not much room, so I'm going to try to make as much space as I can. If your student needs extra sheets of paper to come home so they can do the show work, please let your student's teacher know. Like, I know me, EMSF, we're perfectly fine with it. Please let us know. We will send home plenty of paper. So for A, we have 5,753, 5,753, and then we have 5,781, 5,781, okay? We want to know, is this one less than? I would strongly recommend, because I know some students, they get confused when it says this, or I don't know if it's confusion or just not reading it thoroughly. But when they see less, I want them to go ahead and put their symbol. Okay, that's what that one is. So that's saying that this number is smaller than this number. So if I go over here in my thousands place, I have 5 and 5. Those are the same. So go to the next one. We have 7 and 7. They're the same. Go to the next. 5 and 8. Are those the same or different? They're different. Which one's smaller? It is the 5. So is that the smaller number? Is it less? Yes, it is. So actually the answer is A. However, some students, they may be just guessing. Usually, I tell the students to keep working through because we are all human and we all make mistakes. So I would strongly recommend still going through the other 3 just as a, precaution. because then if you get to a point where you think you have multiples correct, then you can see if you can ask yourself like, okay, where did I make my mistake? B, again, I see this number is greater, so I know that is my sign, greater, and then it gives me this. So again, I'm going to stack them, 5,624, 5,624, and then 5,624, 5,624. I know some students are like, oh, I can do this in my head. I can see that these are the same. A very select few can do that, but please tell them to still put it down. Please show their work still, because sometimes we're moving too fast and what we think is written down sometimes is not. Sometimes the numbers are just flopped just a little. But in this one, 5 and 5 are the same, 6 and 6 are the same, 2 and 2 are the same, 4 and 4 are the same. So is this one greater? And the answer is no, because they're equal. They're both the same exact digits. So that's how that one's wrong. This one, 5,703, 5,699. Again, we want this one to be less. So 5 and 5, those are the same. 7 and 6, oh, those are different. Which one's less is the 6. But hold on, this one says that the 7's bigger, or should be less. And you know that 6 is less, so this is not a true statement. And then we have 5,375, and then 5,537. So if you're realizing both of these have the exact same digits, this is one that I was talking about, how students are like, oh, they're the same numbers. And it's just because we got to slow down. They're different numbers, but again, they're the same digits, just in different spots. So this is saying that this is greater. So 5 and 5, those are the same. 3 and 5, those are different. Which one's bigger? It's the 5. Okay, well, hold on. The 5, 5 is on this side. So this one could not be greater. So that is why that one is not true. So A is your answer on that specific one. All right, this next one says to place the numbers in the correct box. On their test, they will have to click these, and then they'll move them over. Okay. The students also need to realize that it's asking least to greatest. So we got some up here, and we got least, greatest. And then you need to ask your students, let them know, or then ask them, what does least mean? Oh, least means smallest. What does greatest mean? It means the largest. All right, so now that we know that students know that least is smallest and greatest is largest, students, since it's on paper, we can just use this since all these numbers are stacked. However, if this was their test, this would be on a computer, so students would need to copy these 3 numbers onto a sheet of paper for show work, so that way they could stack them. Okay. Again, we go with the largest place value, 5, 5, and 5. Those are all the same. Next, we have 3, 8, and 3. Well, which is the smallest? Okay, well, we have 3s. We have 2 3s. So for a moment, let me use this pencil. For a moment, we're just going to scratch it, not worry about that middle one, because we want to know the smallest. So 3 and 3, those are the same. And then next, we have a 4 and a 2. Well, which one's the smallest? This one is the smallest. So I'm going to go ahead and copy that. That's the 5,329. Again, students would just click and drag it over. All right, and then scratch it out when you're done so you don't get confused. And then, we start over. 5 and 5 are the same. 3 and 8. Which one's smallest? It would be the 3. So again, this number we would put here, 5,346, and then cross it off when you're done, which only leaves you with one, which is 5,851. Okay, please make sure your student is reading these, because we have seen many times that they don't read. Students are just assuming that's either least to greatest or greatest to least. So they do whatever they are assuming, and then we're not doing it correctly and getting the answer wrong. In order to get this problem right, all 3 of these numbers would have to be placed correctly in the correct spot. All right, next we have this one, number 7. It says an ice cream shop kept track of how many ice cream cones they sold each week for a month. So we have a tally, but not a tally chart. We have a chart with our data. We have weeks 1, 2, 3, 4. We have the number of ice cream cones sold with our data 327, 358, 341, and 395. And this type of problem, students more than likely are going to say, I can't do show work for this, which we are fine with. However, I do want them to be asking themselves before they continue, what exactly do we want to find out? Okay. So my question is, in order to have enough ice cream cones to sell for the next month, what do we do? So how are we going to use the data from this month to help us figure out how much we need to have for next month? Okay. So A says to estimate how many ice cream cones they sold last month to predict how many they might sell the next month. So estimating would sound fantastic. I'm going to put an M for a maybe on this one. However, this one is not going to be your answer at the end of the day. And it is because we don't want to necessarily estimate how many we sold. Because if we just estimate these numbers with using one of the 3 that we learned this year, you're going to get a lot of different answers. So give me a moment and we're going to circle back. If students want to put an M for maybe, that is fine. But we'll talk about it in just a second. All right. B says to subtract the number of ice cream cones they sold in the first week from the number of cones they sold in the second week. Well, the first week they sold 327. Second week we had 358. If we're subtracting, that means that we're just finding the difference that was sold in week 1 to week 2. How is that going to help us find out how many we might be selling for next month? Okay. And it's not. At the end of the day, that's not going to help. This one is not a correct answer. But having your student talk to you and say, you know what, that doesn't make sense. That's not going to help me figure out how many ice cream cones I need to have for next month. Next, C says, estimate how many customers they think will want to buy an ice cream cone. Again, this one has nothing to do with even what our data is saying, okay? Because this is just the number of ice cream cones sold. We don't know how many customers came to the store or the shop and bought ice cream, right? Like this could have just been one person. Maybe they bought it for a whole school, and that's why they needed 327. We don't know. Maybe it was 327 different people, and they each just bought one. Okay, so this C is not right because we are not worried about how many customers. We want to talk about ice cream cones. And then D says to find the exact number of ice cream cones they sold last month because that amount will be the same for the next month. And that is not true either. So if students go with an M for this one, this is why we wanted to come back to circle back, okay? I was mistaken. A is going to be your answer. I apologize. However, the main difference with this one, okay, yes, finding the exact number of ice cream cones they sold last month is going to be helpful. Okay, that first part, it would be incredibly helpful, right? To find the exact number of ice cream cones they sold last month. That is the helpful part. This last portion, it says, because that amount will be the same for the next month. There's no way for anyone to know exactly how many you're going to sell. Because it's not how it works. Because if they always sold the exact same amount, I don't think they would be keeping track. Because if they know they're selling only 50, they're probably only going to make 50. So if students can get down to A and D, it's going to really help them out. For this specific problem, I apologize at the beginning of this one. I had said it wasn't going to be A. Again, I did not read ahead of time the rest of the sentence prior to this. So for this one, your answer is going to be A. We are going to just estimate how much we sold to help us predict. Yeah, I don't. These type are really difficult for the students to get, because while students know that if we find out the exact number, then we could estimate about how many we may do next month. And that is something like all the students have really been kind of gearing more to and like understanding better. But then we get problems like this where we know that estimating is not always the best strategy, but we also know that just because you sold a certain amount, an exact number, 1 month does not mean that it's going to be the exact same. And that's what this is. That's what D says, that they will be the same. So that is why D is not right. It's because it says that both months would be the same. So A is going to be our answer. I apologize. I had previously, when I started it, I said it was not. But that also just shows the students I'm also human, and that we need to make sure we are reading and thinking about each of these. All right. Number 8 says, number 8 is a word problem, which has been tough for a lot of our kiddos. This one says there were 493 fish at the aquarium. 159 more fish were added. Which strategy gives the closest estimate to the total number of fish in the aquarium? So this specific question, students would have to figure out which estimation strategy to use. We've been talking in class when we do these type of word problems, and then it asks you for the closest estimate to the total number of fish in the aquarium. Have your student actually solve the problem. Okay, so there's 493, there's 159. Even if your kiddo has a hard time with reading, we know we're adding, because every single option is adding. So that is a good giveaway of what we are doing. Then also ask for the total number. So that's another one. 3 plus 9 is 12. Carry your 1. 1 plus 9 is 10. 10 plus 5 is 15. 1 plus 4 is 5. 5 plus 1 is 6. We have 652. And then which one of these is closest to 652? It would be B. Now I know this had gotten a lot of families, because most of us adults, when we went through school, we learned to round to usually like the nearest 100. So if we did that, then you would probably do like 500 plus 200, which would get you 700. So yes, rounding is one strategy, but it does not get you as close. Okay, so if you used the rounding strategy, you would have chosen D, but it would be wrong. If you would chose to do front end, what is it called? Front end estimation. That means you would take the first digit of each one, which would be 4. So you would have did 400. Right here is a 1. So it would have been 100. So 400 plus 100 would have been 500. So if you did front end estimation, you would have done C, which also would be wrong, because as we can see, 500 is a long ways from 652. And then B is chosen because that estimation strategy is called compatible numbers, which overall just means that we're trying to make it easier to typically add or subtract, because the numbers are using more zeros and 5s. So if we look at 493, if you're using that compatible number, students would probably go, let's do 500. Some students would go to 495, but that's not an option. So 500 would have worked, which is what we would do here. And then same thing with compatible numbers. We would either do 150 or 160. something like that. In this specific one, they only have 150, so we got the 650. A lot of the kiddos were getting very confused with the different estimation strategies. So please just have your child solve it, get their answer, and whatever one is closest to this answer will be your answer. So 650 is closest to 652. That was number 8. So now we're on number 9. A flower shop has 152 roses. There are 65 more daisies than roses. How many daisies does the flower shop have? Some kiddos like to make the box, and then like this. This is like a part whole strategy. That's what they usually use these boxes for. We see we have 2 numbers, so we know the bottom box will be into 2 different parts. So then that's when it just comes to asking yourself, what are we trying to figure out? We're trying to figure out how many daisies we have. And so that question comes to find out, is that a piece or is that the total? And this specific one is going to be the total, because we know that we have this many roses and that we know we have this many more daisies in the roses. So we are going to want to add. So if I had put them in the box, 152 plus 65. If it's down here, we add. So 152 plus 65, 152 plus 65. 2 plus 5 is 7. 5 plus 6 is 11. Oops. And 1 plus 1 is 2. So 217 would be your answer. Our kiddos who do not like to show their work when they have to regroup. So 5 plus 6 is 11. I have a lot of kiddos who just write a 1 and they don't put this up here. But if they forgot it, then they would have just had 1 plus nothing. And many students would put 1. And that's also an option. So that's why it's very important for your students to show their work, especially when they're regrouping and borrowing. Okay. This one was hard for a lot of kiddos. This is the equality. Every single one of these needs to have show work. So what is 15 minus 5? Some kids can do it in their head. They know it's 10. Others need to write it out, which is fine. 5 minus 5 is 0. 1 minus nothing is 1. So we have 10. 8 plus 2 is 10. 10 and 10, are those the same or different? They're the same, which is why they're equal. Again, on the computer, students will have to click this and put it in the box. 6 plus 6 is 12. 12 minus 6 is 6. Are those the same or different? They're different. Well, my options is either equal or not equal. So this instance, they are not equal. Again, they'll click it, move it up. All of this, they would be able to put and write on a separate sheet of paper as their show work. 4 plus 6 is 10. 7 plus 5 is 12. 10 and 12, those are different. So again, this one is not equal. They would need to have all 3 of these correct in order for this problem to be shown as correct. Number 11. Emily wants to find the answer to the question in the box. So what is the most popular car color sold in a month? Well, which of these questions would be the best way for Emily to collect data to find an answer to her question? So ask your kiddo, what did we want to know? We want to know what is the most popular car color sold in 1 month. That's what we want. Car color. So A, conduct an experiment to see which car color is the best. Is that helping us tell us anything about what was sold? Do we care what's the best? No, we don't. So it's not A. B, survey all of her friends to find out what color car is their favorite. Well, are we asking what is everyone's favorite color car? We're not. We want to find out what color car had the most sold. So this one is no. C, It says collect data from car companies that show how many times each color car was sold in a month. And students hopefully are thinking, that might be it, right? Because I tell students over and over again, do not ever choose one that you think might be it. Always read them all. So I'm going to put a maybe, because that would help us if I find out from those car companies, hey, how many red cars were bought that month? Or blue, or, whatever colors. And then D says create a tally chart to record the number of times she sees each color car in a parking lot. And this one is not correct because we do not care. It's not, well, I don't say we don't care, but it's not what we're asking. We're not looking for how often we're seeing things in a parking lot, or how often, how many times do I see your black car in one day? We don't want to know that. We want to know how many are sold. All right, so this has sold, this has sold. So hopefully they can kind of see that that's why C would be the answer for this one. But it is a lot of just reading and stop and think. Does that answer my question? Okay. And then lastly, this one is really tough for a lot of kiddos. It says look at the data in this tally chart. And we've got the soccer team points, and then which bar graph correctly displays this information. Every student needs to know that a graph is not a graph if we don't have TLC. Okay, this is great show work. Okay, if students just write TLC, that's perfect, because we're going to use it like a checklist. You parents, we are going to say that T, that's the title. Ask your student, what does the T mean in TLC? They should know that it is the title. L are your labels, and C are the categories. Again, students do not need to write this. I'm just trying to help you, the parents. I strongly recommend students count their tallies and write it on the sides before they even look at the graphs, just because it helps make it a little easier. So for this one, I can see there's 5, 6, 7. This one is 5. Hawks is 10. Panthers is 4. And then those Rangers are 5. Okay. So which graph correctly displays this information? And a lot of students are going to want to take this, just the data, and look in here. But in fact, I need them to look at the data last. Okay. This is 3rd grade. We are no longer asking only what is the data and if the data is correct. Okay. Our first question for each one is TLC. Okay. I'm going to write it over here because it's going to make more sense in a minute. All right. Again, that is just for a checklist. Okay. So for A, does it have a title? Soccer team points? Yes. Perfect. Does A have labels? Labels would be telling me what this is for. Labels would be telling me what these are. So does A have labels? And it does not. A graph is not a graph if it does not have TLC. So A could not be it. Okay. We come down to B, right? Does it have a title? Yes. I'm going to check it. Labels. Does it have labels? Well, yeah, I have points scored and a team. Perfect. And do I have categories? Categories are these right here. The Cubs, Turtles, Hawks, Panthers, Rangers. Does it have that? Yes. Okay. At this point, that is when we go back and look at data. But again, Ms. Cromwell says, do not go. Don't look at the data. Don't just choose one. If it's the first one, let's double check. So we're going to come back to this. C, does it have a title? Soccer team points? Yes. Does it have a label? Well, I have a label here, but do I have a label here? Nope, I do not. So since it does not have all of the labels needed, it is not a real graph. Okay, we come down to D. Does it have a title? Yes, it does. Does it have labels? Yes, it does. Do I have title? Yes. Labels? Yes. Does it have my categories? And that's these down here. Yes, it does. So this, okay, so now we're down to 2. We're down to B and D. And now we want to come up and we're looking for those 7 Cubs, the 5 Turtles, the 10 Hawks. A lot of kiddos, we were practicing this week or last week. They looked at the largest one. They said Hawks had 10. Let me see if these have 10. So if you go to Hawks goes here, which is in between 4 and 6. So that is 5. This one only has 5 Hawks, but this Hawks goes all the way to the 10. So D is your answer. Okay. If students were only looking at the data to begin with, then students, because I hear this every year, students would say, Ms. Cromwell, there are 3 correct answers because A, C, and D all have the correct data. They all have the 7 Cubs, the 5 Turtles, 10 Hawks, 4 Panthers, and 5 Rangers. Okay? And then I get a lot of upset students. They're like, I can't figure it out. There's 3 answers and I can only choose one. And it's because they don't think about going through and doing TLC for each one. Okay? TLC for each one, then the data. All right, if you have any questions, concerns, if anything didn't make sense, or if you need more practice on something for your student, please reach out. I will get you some resources. Thanks and have a great day.